Hi, my name is Skylar Hogan, and I'm doing the nitrogen system, or the nitrogen cycle, I should say. So, just some quick definitions so that they're out of the way before I start talking. Nitrogen fixation is when nitrogen moves from the atmosphere to the soil, and the nitrogen is in the air is actually unusable for the plants, the gas form of it. So, the nitrogen fixation occurs from metabolic processes from bacteria in the soil or on plant roots. So nitrification is the ammonia in the soil is converted to nitrites and nitrites and nitrates. Denitrification is nitrogen returns to the air as nitrates are converted to atmospheric nitrogen by bacteria. And a symbiotic relationship is a relationship where both parties benefit. So the definitions and diagrams. I don't know if you can see this because of my webcam, but if you can, then I'll just go to the first slide. So the definition is a series of processes by which nitrogen and its compounds are interconverted in the environment and in living organisms, including nitrogen fixation and decomposition. So I don't know if you can see that, so I'll just go to the first slide. So we'll start at atmospheric nitrogen right at the top. It goes either through lightning or sometimes fires can can fix it so the plants can use it. Or there's nitrogen fixing bacteria in the roots or in the soil that you can see on the left there that also fix it into ammonia. And then nitrification turns it into nitrates and nitrites and traits. I don't know if you can hear the difference in that. But then denitrification then turns it back into the gas. Alright, so the important Earth systems, the atmosphere plays an important role because it contains a huge pool of the nitrogen gas, and about 78 of our atmosphere is nitrogen. The biosphere is where the... One second, I got notes on my phone here. The biosphere is where nitrogen becomes usable by nitrogen fixation. It can also become usable from lightning strikes or fire, like I said, but most of it becomes useful from the bacteria, and the biosphere also contributes to circulation because a large portion of where the nitrogen circulates is in the biosphere. The hydrosphere plays a role because seawater dissolves nitrogen gas, and that will make it useful for the organisms in the water, and water also receives a lot of nitrogen from fertilizer. This happens when there's too much fertilizer added and it's washed away by the rain. Alright, how it is transferred. So, to get the nitrogen to the plants, bacteria will make nitrogen usable by converting the gas into a nitrate through nitrogen fixing. Some plants will form a symbiotic relationship with the bacteria and let the bacteria live on the roots. This causes a symbiotic relationship, and this symbiotic relationship is because it benefits the bacteria because they get energy from the plant, and it benefits the plant because it gets usable nitrogen from the bacteria. The animals get nitrogen because they'll eat the plants that just took the nitrogen from the bacteria. And humans will get it because they'll eat the plants or they'll eat the animals that just ate the plants. The atmosphere then receives nitrogen from the bacteria that changes it back into a gas through denitrification. What's the wrong way? Alright, the oceans part in all of this. So the nitrogen gas, or N2, dissolves into seawater at the ocean surface. The seawater dissolves it. And the nitrogen is then converted to ammonium from different microbes through nitrogen fixation. When the organisms die, they decompose and release ammonium and tiny particles that contain nitrogen into the seawater. Some microbes convert ammonium to nitrite and then nitrite to nitrate. This is called nitrification, and that's the result. The result of this process is the nitrate is released into the ocean. Organisms then consume particulate nitrogen and dissolves organic nitrogen, converting some of the nitrogen back to ammonium. This process is called remineralization, and to complete the cycle, some microbes convert nitrate and nitrite back to gas through denitrification. And then I move this up so that hopefully you can see it around my little face in the corner. So many human activities have a significant impact on the nitrogen cycle. Burning fossil fuels, application of fertilizers, and other activities can increase the amount of nitrogen in the ecosystem. Industrial nitrogen fixation has increased exponentially since the 1940s, and human activity has doubled the amount of global nitrogen fixation. In agricultural systems, fertilizers are used extensively to increase plant production, but the unused nitrogen, usually in the form of nitrate, can leach out of the soil, enter streams and rivers, and ultimately make its way into the drinking water. The process of making the fertilizers is by causing nitrogen and hydrogen to react with each other, and that's known as the Haber-Bosch process, and it has increased significantly over the past few decades. As you can see with the tractor here, like the exhaust gases will also put nitrogen in the air, as well as fossil fuels, and like the fertilizer here, that'll put excess nitrogen into the soil, which then gets into the water, and then it'll just keep cycling through.